Well, good afternoon. My name is Fred Yentz. I will be the moderator and host of this session. I look forward to really being entertained by three very smart folks in the world of IoT. And let me tell you a little bit about myself and a little bit about that logo in the upper left. So again, my name is Fred Yentz. I'm the president of a company called IoT Launch. IoT Launch is really about putting ecosystems, developers, buyers, promoters together in the IoT space. I was the president of IoT platforms for Telit for many years. And it's really good to take and leverage what I like to think of as the only two good things that come with age: wisdom and your personal network. Everything else is a lie when they talk about what happens when you get a little older. So with that, that's a little bit about me. IMC is the IoT M2M Council. And what IOC does, think of us as a trade association. We have 28,000 members, and we put makers of IoT and buyers of IoT together. There's many people in the market that make product, and they're expert engineers in making their product. They may not yet be expert engineers in making a connected product. So in the embedded world, it's wonderful to see all the technologies and all the things happening. And this is really something that very few people are designing non-connected assets. There's some network element today, and I think most folks want to have products sold at scale, whether that's millions of products in Germany or thousands of products in hundreds of countries around the world. So scale means different things to different people. So the format for today is we've got Rony, Aitor, and Carmen. I'm going to each have them come up, take you through a few slides, talk about their company, what they do, and let them give you some context of why they're here today. And then when the third presenter is done, we'll bring them up and we'll have some Q&As and some discussions. I have no problem even bringing some questions to the audience, if that makes sense. We do have one mic that we'll figure out if we need to run one around, but that would be good, or shout it out and I can repeat a question. But with that, I'd like to introduce Rony. Rony Cohen is co-founder and head of business development of a very innovative company called floLIVE. Take any one of these. This one? Both work.
Is this working? Okay, great. Thank you very much, everyone. So yeah, I'm Rony Cohen. I'm one of the founders of floLIVE, and we're a connectivity company. So we're in the IoT space, connecting devices globally in the cellular world. We now, I guess, the one thing that's not just cellular is that the satellite has come into our ecosystem as well, and that's sort of joining us. But what I'll talk a little bit about our network and how we see the connectivity between the design of connectivity itself, as well as designing in this environment, designing the boards, designing the different aspects of connectivity inside your product, and what Fred was saying about, millions of devices in various places in the world and how that all fits together. So I kind of wanted to go back to a point at the beginning of digital transformation, just sort of a minute about it, to put some context about it. And I was going to sort of, when I was trying to think about this, I was saying, what happened to digital transformation in the last sort of 10, 15 years, 20 years? So we've seen sort of digital transformation come from every aspect of our lives, from the financial services, from automating processes inside healthcare systems, etc. What we haven't seen much is the connectivity side. So the connectivity really hasn't evolved much, apart from the fact that we've seen sort of faster speeds, 3G, 4G, 5G, we've seen that, but really that digital transformation hasn't touched the connectivity side. And I think that's where we felt that there was a point to build a stronger offering. Personally, I've sort of built mobile operators in various places in the world for the last 20 years, since the late 90s. And there was a point where I thought we need to build the largest mobile operator in the world, but really how do we do it without being geographically constrained to a certain area? And really, that's the formation of floLIVE. I guess the way we see it is that we are here to do what AWS did in the IT world, how they adapted digital transformation. We did this in sort of in the telecom, in the cellular side, for devices and for connectivity for devices. So I'll give a little bit about our network, what it is, and how it started. We set out on a large mission, which we didn't really know how it's going to turn out, but it turned out quite amazing, bigger than what we have ever expected. And we really turned out to have a number of locations around the world. But we built a carrier-grade core network infrastructure for the cellular world, for the mobile world. And what we've built is core network infrastructure. Some of you who may are more familiar with it, so the HLR, the HSS, the packet gateways, everything that's in the center of a mobile operator's, whatever is not the RAN, whatever is not the antennas, it's in the center. So this is what we've built, and we've written every line of code for this, and we've distributed this all over the world. So de facto, you're looking at the largest mobile operator in the world by infrastructure without the antennas. And we've partnered with 25 of the world's largest groups who are authenticating on our core network. And when we provide a SIM card to a customer, that SIM card authenticates on our infrastructure. And that gives a consistent service across the world for our customers. It's a cloud central managed platform. However, it has locations all around the world, Latin America, North America, and Africa, in Asia, Australia now. What the platform really is, a connectivity management platform, a SIM management platform, and I'll talk about that in a second. The SIM management is where we put an EUICC container, what you all know as a profile in eSIM profile, but we put a multi-IMSI on top of that. That means that there's multiple IMSIs inside one SIM card, and they can transfer between each one of the IMSIs dynamically, depending on the business needs and the RAT types, etc., or your device needs. It really comes down to a globally consistent behavior across your network. So if you've got devices, you've designed devices that need to be in multiple places in the world, you have customers who are deploying this in the US, as well as in Asia, as well as in Europe, you really want everything to behave in the same way, and you want to be managing it in the same way. So when you're managing it, if you took the SIM card from, or the connectivity from a mobile operator, you'll have to integrate with their APIs. If you move to another mobile operator in the US, you'll have to integrate with their APIs. And some of them don't have narrowband, and some of them do have narrowband, and some of them don't have this RAT type or the other. So you get the point. There's quite a big matrix of this, and we'll touch upon that actually in my last slide. By numbers, there's 25 carriers, meaning that these carriers authenticate on our core network. We're not using their infrastructure, we're only using their antennas. The IMSIs, the identities of the SIM, are authenticated on our cores. We have 40 core network POPs and 70 packet gateways, meaning you can take an AT&T IMSI from us, but if your customer is in South Africa, you would terminate in Cape Town. Data would be terminated in Cape Town, so the last mile will be terminated there and not transversed back to the US. And that's really important across. If you think about that, you think about latency, you think about transporting data all across the world. If you think about that in low latency and high latency, that has a lot of effects, especially when you're designing your product. You've got to think about that. Roaming really transverses the data, what is called the home routing, and goes all the way back to the home carrier, then terminates to the internet. If your application is in South Africa, as I gave an example, your data will go all the way back to the US and then all the way back through the internet back to South Africa. So that routing is probably 200 milliseconds, which you don't really need. If you're looking at battery life, if you're looking at a battery-operated IoT device, you really want to be as efficient as you can. I'll give you an example without mentioning a customer name. It's between 350 milliseconds and 100 milliseconds is between 6 months of battery life and 2 months of battery life. So, and that's a device that polls itself 2 or 3 times a day. So just to give you that as a consideration, there's many other reasons why latency and termination of data is extremely important, because GDPR, financial services require data to reside in certain areas. When you're terminating or you're doing a financial transaction on a credit card on a point of sale device, the data of the transaction needs to reside locally. So there are many reasons why, apart from just technical as well. Just give a bit about our platform. These are essentially what our platform looks like. It serves the MNOs, it serves the IoT service providers, what we call the MVNOs, and the OEMs. A lot of the OEMs could be sort of pretty much any industry you can think of, but some of our large ones are obviously transport, logistics, all the tracking devices around that. That's a very large piece of the market, but solar panels and the water meters and the even sort of in the retail, all the iPads now, where you're coming into a retail store and they check, if you've got the stock or not. What started from a few thousand sort of iPads is now in the hundreds of thousands, but it's sort of split, I would say, if you're thinking about that, it's sort of split between high bandwidth and low bandwidth applications. And I think you need to think about that when you're designing this. You need to think about your application type when designing high bandwidth or low bandwidth applications. A lot to do with the modems, a lot to do with when I was speaking about latency, for example. I was having a chat with Carmen this afternoon about how antennas as well affect the latency. So when you're designing a device, eventually when it comes into the enclosure, really want to optimize as much, even in the sense that you're choosing the right antennas for your right, modules. And we're integrated obviously with many of the module manufacturers, because the eSIM comes within, so you can get the eSIM and the connectivity inside the modems. So just to give us an example, a lot of the IoT MVNOs that we power is about, I'd say about 15 or so IoT MVNOs who use our infrastructure. We're sort of the infrastructure behind them. They use one or part of our networks, the core network infrastructure, which is distributed, the EUICC, the remote SIM provisioning, the connectivity management platform, which really gives a deep down, because as I mentioned before, all our connectivity authenticates on our core, all the data terminates on our packet gateways around the world. That means you get a lot of data, a lot of signaling data from us. So, our customers who are building devices can get information which they sort of feed back to their device. They could see the towers, they could see the locations, they could see which aspects of data is being pushed or not pushed at certain times. They get all that data from our APIs. And we have the consumer eSIM as well, which is, we won't go into a SGP32 now, but it's the M2M side of it. And our MVNE platform allows really our customers to build a service-based IoT device. So where you're moving from selling a device to providing it as a service. Are we all right for time? Am I? Yeah? Okay. I wanted to sort of just to sort of throw even more confusion at everything I've said, but what I call the complexity of the IoT value chain. I just realized the screen is here, so I don't have to look at it. I was trying to sort of give an example of why this is always complicated, and why I think everybody here who's ever sort of read anything about IoT would see there's so many articles about why 90% of IoT projects fail, and why, there's quite a scary sort of story around it. I think in a sense it's true, because things, this industry is quite young, we're probably about, I think when we start coining the word, the term sort of machine to machine was probably around 2010 or so. And the complexities are really what we call the IoT matrix, the multi-dimensional matrix. And give an example, although there's tens of vendors in the sort of in the module space. You know, everyone makes a modem. We work with many of these companies, with Qualcomm. Qualcomm is an investor in floLIVE as well. But we work with all of them, with Telit and with Sony, and work with most of the partners here. And what I was trying to show is that each one of these module makers, when you're designing a device, you need to make a choice of one of these devices. Now, within one of these devices, there's tens of different variations, which really rely on what you're deciding to build, where that device is going. Is it going to be in Europe? Is it going to be in the US? Do you want one that works everywhere? Do you want one that's multi-band? Is it going to be in some places, in some parts of the world, narrowband doesn't exist, but maybe you want to use CAT-M, CAT-M1, but maybe CAT-M bis now that you CAT-M1 bis, which is sort of more battery power efficient. So, or you're going to use 5G RedCap. There's a lot of various options, and you sort of need to now make a decision around it. So you need to choose this is what I was saying about what sort of cellular technology you're looking at, and then the OEMs. Now you're looking at the OEM and you think, okay, do I need a single SKU? Do I need to build this at factory? Do I need to go through certification in certain areas in the world? And where I say that this is the multi-dimensional matrix of what you're looking at when you're deciding to build this. In a way, we've solved a majority of this. You still have to make your decisions of the hardware you're going to use, but I think that where floLIVE has come is really to solve it from here onwards, because our network is available in all these technologies if the antennas are there to support it. So you don't have to think about whether or not, you know, the mobile operator that you've chosen supports narrowband. In most countries, you know, we would support 2 or 3 mobile operators terminating locally with local IP addresses, with local termination. I'll just give a little bit of sort of insight into sort of the car industry, some of the basic issues where you're looking at a SIM card that doesn't terminate, a device that doesn't terminate locally. Infotainment has a major issue when you're looking at your devices terminating with a roaming SIM. You can find yourself with adverts in various languages that are not the languages that the car is being driven in. Clocks are being manipulated by IP addresses from various other places in the world. And then when latency comes along, or if you've got internet issues along the way, you're really suffering with that. So infotainment perhaps is not a critical, mission-critical application, but software updates are. And for software updates, you really want the absolute best, and that's why we always say, you know, a multi-net within a country. So 2 to 3 carriers within a country, always getting some sort of service there. So perhaps I mentioned some of the last slide already. Which of the cellular technologies, that's what I already discussed. I think this is a key part at the beginning. What is your required bandwidth? Again, the low bandwidth, high bandwidth application. And what's the maximum latency your device can handle? And that's really a key consideration here. And it's a key part of the design process as well. In what geographies, how does your device behave? You know, is it really important for it to be alive all the time? Is it really important to be, can it go to sleep? Is it required to go to sleep? And again, there's a lot of considerations about saving a battery-operated device when you can sort of put them in a dormant stage. There's a lot that we could do on the network side as well. So it's not all about the hardware. A lot of what we've discussed here, we can also adapt with the hardware. We could create we can decide not to poll the device if we don't want to wake it up, and we can decide to do that from the network. So it's not just about the hardware. What's your power saving needs? Again, there's a lot that goes into power, but as I said, we've worked a lot with our OEM partners around power power savior, power management. As I said, it's so important if you've got a device that, what I gave a device about sort of a 2 months to 6 months, you're looking at devices that perhaps are, they get thrown away after 6 months, or maybe they're very small trackers, etc. So the price has to be right. I mean, there's no point in doing that when a device is very expensive. But yeah, that's about, and you require network redundancy. So again, mission critical stuff is definitely needs more consideration. I'll talk about this maybe perhaps afterwards. Okay, we'll talk. So thank you very much.
Thank you, Rony. So now I'd like to, so that's the network. So now you're in the network side, you know you can go everywhere. The next thing you need to worry about is the device. And as you've wandered around this show floor, I would say that every year or every few years, Embedded World kind of takes on some unique themes. And I would say this year's kind of a theme of the antenna. Everybody seems to be talking about the challenges of some antenna products that have to go into your solutions. So with that, I'd like to introduce the next speaker to talk a little bit about his stuff here. And Ignion, take it away.
Thank you so much, Fred, and thank you for having us. My name is Aitor Moreno. I'm Cloud Product Manager at Ignion. And well, as Rony did, I will go through the different challenges we see when deploying devices in a global scale. I will talk a little bit about Ignion, what we do, who we are, and then maybe spend a little bit of time talking about what new platform that we have launched recently here at the Embedded World. So we do antennas. That's what describes Ignion. And we only do RF, which we normally know. We know that those ones that are in the industry, that RF is sometimes a kind of a black box or a mysterious box. No, Carmen, I think that you agree with that. So we try to focus on that. We make the customer success our North Star. We are global. Even if we are a company based in Spain, we have a global footprint. And we have more than 20 years of experience. No? We started with a different company name, then we rebranded as Ignion some years ago already. And we have been addressing our customer needs in the antenna domain with our virtual antenna technology. So for those of you that don't know the virtual antenna technology, it's a different way of thinking about antennas. It's non-resonant elements that could be adjusted to different frequency needs. And at some point, if you have further questions, of course, we can discuss. We have a proven RF track record. We have more than 50 million IoT devices powered by our virtual antenna technology. We have a lot of patents. Virtual antenna technology is patented, and we are protecting also our IP here as well. But we want to focus on one of our missions when we talk about antenna is, as I said, customer success. We always try to be close to customers. We always try to make it as simple as possible. And of course, understanding the challenges helps us addressing those challenges. So, well, Rony has explained really well the different challenges from an infrastructure standpoint, from a network standpoint, and in the IoT in general. I totally agree with you that we have kind of a multidimensional matrix with a lot of decisions to make. And we see from an antenna standpoint plenty of different challenges when it comes to building a new IoT device. I have listed here a few of them. Coupling effects, worldwide coverage, which is actually the topic of that talk. Materials in proximity. We sometimes forget about that our devices will be operating in the real world, so free space, it's not realistic. We have materials in the surroundings that impact the performance. Certifications, depending on where do you want to deploy your product, where do you want to operate. So certifications need to be considered. And last but not least, battery life. Antenna has a huge impact in battery life, and having a good efficiency and a good performance in terms of antenna helps supporting this battery life. So what do we do at Ignion? As I said, we have some challenges in the IoT space. We know that RF is hard. That's why we try to make it easy through our simplified portfolio. We also have our own platform that I will talk about just after this slide. And we try to make this technology accessible for everyone and the knowledge around RF accessible for everyone. This is kind of our visions and where we are, of course, putting our efforts. Our products are support multiple bands and all the new standards. It's coming just as some specifications here. It's coming from 450 megahertz up to 10 gig. We cover the full frequency span in that one. We support small designs. We know that having small form factors is critical when you are designing a device. We are every year going smaller and smaller in terms of form factor, so it's important to also keep the pace on that one. Antenna as an afterthought, and I think, again, this is something we share with Kyocera in that case. Antenna, we would love that you guys as designers, as engineers, consider the antenna from the very beginning. We normally use the analogy of a car, so antenna could be seen as the tire of a car. Maybe it's not the most important piece. We have the engine, but you may have the most fancy car with a super cool engine, super powerful, but if you don't have a good tire, it will not move. So that's why having a good antenna when you're designing wireless devices, it's important. So please keep it in mind from day one. And last but not least, we would love to have more RF engineers. Maybe there is some of you guys here in the audience. So we need to make sure that this technology, this knowledge around RF, it's accessible for everyone. And actually, this is why here at Embedded World we have launched Oxion. Oxion is our AI-powered antenna integration platform. I was speaking 2 days ago in Hall 3, presenting that to the world. And you may be asking why Ignion, an antenna company, is working on a software solution, no? A platform solution, actually hosted in the cloud. Because in that way of making things simple, we believe that this kind of features play a key role. So by having this type of tools accessible to everyone, which is actually free of charge, you can start building and considering the challenge of RF from day one and have a really good guidance from concept to market on what is actually needed from the antenna standpoint. So a little bit of headlines on what you could find or why we are building that platform. I have already mentioned a few of them. We want to make RF transparent for everyone. We have huge experience there, and we want to share that experience. Real-time performance tweaking. Tweaking is a word that it's like sounding a lot lately at Ignion, and that's why. And why we're mentioning that a lot. It's because we are using the power of AI. That is actually the latest one. We have built our own ML model, so we can provide real-time performance estimations based on different design iterations. Now, we understand that an ideal scenario is not always possible, so you need to adjust your design requirements. In that case, of course, we are mentioning or we are talking about antenna-related, so antenna location, which means feeding line at the end, clearance area, and PCB dimensions. So you can just play and interact with different design versions for your device and see in real time what is the impact in performance, which at the end is the goal. The ultimate goal is to take better and informed decisions. That's our main goal. And as a last slide, I would like to talk about a success story. Actually, I have it with me. This is a super thin. This is thin track, and it's a super thin and ultra power tracker. It's used actually to track envelopes, and it has a global deployment. So here we're integrating our antenna, 3OM extent, and actually if you come by our booth, we can further discuss about that, and we can showcase more examples. In that product, we have global cellular. We also integrate GPS, Wi-Fi, and Bluetooth, all in this super thin device. So this is where what I was saying at the beginning, a small factor type of devices with challenges from an antenna standpoint and connectivity standpoint, it's something where we can help you. And I think that's it from my side. Thank you so much. And I leave the floor to Carmen. Thank you.
Very good. And next. Next, it's my pleasure to introduce Carmen from Kyocera.
Hi. Hello, everyone. Thank you very much. Well, I'm very happy to see two antenna companies presenting for once. Normally, you see more than module makers and connectivity partners. And antenna is always the big lost component in our minds. First of all, I'm going to introduce myself because I'm in marketing, but people have a misleading idea when I say marketing. I'm a telecommunication engineer. I'm specialized in antennas, and I have been working 17 years in different roles as an engineer and handling projects, and also now I'm in charge of the global marketing and strategy of Kyocera AVX. So in Kyocera AVX, we are under the umbrella of Kyocera, which is a Japanese company. Of course, we're doing different type of products, do even printers. It's not the first time they come to our booth asking for if we have printers. We are Kyocera AVX, which is a division of Kyocera in advanced electronic components. So as you see, we have different types like capacitors, RF and microwave components, sensors and controls, connectors. I'm in charge in the RF division and specialize in the antennas. And we serve many different markets. We are in the consumer electronics, like in cell phones, laptops, automotive, medical, and of course in IoT. This is one of the reasons we are here supporting this panel. We have, of course, a very global footprint. We have in antennas, we have design centers in Europe, US, in China, Korea, and Japan. China, Korea, and Taiwan. And then we have our factories, Vietnam, China, and Korea. So we are able to support globally all our customers because, as Aitor was saying, it's very important to help our customers to integrate the antenna, test it, verifying, etc. So here's an example of different applications that we can cover and different type of antennas for each. So depending, like for example, when we are looking into this industrial gateways, sometimes you have antennas integrated. Some of them they are like very robust, where you have all metallic, so you need to have external antennas. Wearables is always very challenging, so we have different type of capabilities to do custom designs. It's important to be able to have the best performance in the smallest devices. So one of the capabilities we have is LDS, which is laser direct structuring, where you can have the antenna directly on the plastic. Cheap antennas, we also have active solutions, where we use, for example, for small IoT devices, we are able to switch the different bands depending, the band that the module is using. And in this case, we provide the antenna and also the chipset, so we provide the full solution. This is just an example, but we come back about what is the design process where you integrate the antenna in there, First, you have, of course, the simulations. You can see where you place it. You can do some estimations, and we will discuss later in the panel considerations we need to have. Once you have your estimation where you want to place the antenna, etc., you need to do some prototyping. It's very important to make the mock-up when you see where you will place the antenna, how it's going to affect, and even how you place the cable for this testing is affecting, because everything radiates in those small devices. Then you go through a loop of testing, optimization, validation, etc., until you go to the mass production. Mm-hmm. So here I'm going to add more problems that Aitor was showing. I think he was quite optimistic because we can see not only during the implementation, but after you have your whole device, you can have harmonic issues, you can have noise issues. So there is a lot of different type of problems, which many of them are even unexpected. And this is why it's very important, consider antennas first at the same time as the module, as long as you have a project when you see what is the module you're going to use, what bands, and you know what is the size, that's the right moment to think of the antenna. Not when you have all your electronics done, because then you will have challenges about having the right form factor for the antenna. And then, of course, you need to rely on the experience, on our experience. We have all gone through through these problems, and we can really kind of foresee in advance what you're going to experience for that. When we talk about global connectivity, now the next slide is a bit more focused on the panel's topic today. So we have one software online which is powered by Deutsche Telekom. It's called the IoT Solution Optimizer, which is actually quite powerful because we are able to simulate the whole device battery life. You start selecting what are the countries where you want to deploy your product. So you can select, for example, the US, I don't know, France, Germany, Spain, and then you will be able to have different types of let's say, characteristics, like is your device going to be mostly indoors, it's going to be outdoors, you know, and later, after all that the configurations, you select your module. So all the modules that are selected by Deutsche Telekom or certified, you will be able to select it. Once you have this information, then you have other components, like the batteries, like the antenna, then you will select what antenna, and there you can select, actually, we have provided all the real measurements in different sizes and in different positions. So you can select the antenna in the right form factor for your device, and going through all the process at the end, you will be able to estimate how will be your performance or your battery life. And this will help a lot, you know, the IoT designers to be able to estimate what is going to be your battery life before doing any proof of concept, because this is one of the major failures for the IoT designers. And to finalize, I wanted to open the discussion for the panel, which is that what is next in IoT, how we can have global connectivity. Well, 71% of the world doesn't have terrestrial connectivity. Either it's in the ocean or it's in a remote area. This is why now you will see more and more satellite IoT, like in terms of NTN, you can have a LoRa direct to satellite, and there's a lot of opportunities where we can cover that. So now one of the topics that probably we'll be discussing is how this is working, how you're going to connect your terrestrial, what is the correct connectivity, and but this is kind of what is next, and the goal is to have 100% connectivity in IoT devices. Thank you.
So I would like to invite up the three panelists, the two remaining panelists, to come back up and sit down, and we'll get to a few questions. So you get to share. You guys get to share mics. Figure it out. So first of all, thank you. Three very unique perspectives, quite frankly. When we kicked it off, we talked about millions of devices globally. I think there's different characteristics. If I have millions of water meters in Sydney, Australia, I have a different problem than, you know, thousands of containers traveling globally, right? There's devices can move around, or you can have millions of devices stationary. If we look at this through the optics of the network, Rony, if you could maybe talk about what are some challenges of global and the difference between stationary and mobility.
So the stationary, really what we do with stationary devices, first of all, there's elements of security in there. You don't want to have a device, if a device is stuck in a wall, you really don't want it to move. And if somebody sort of taken out your plastic SIM card or replicated your eSIM, you want to have some IMEI, sort of hardware and IMSI tie-up. So if somebody's replicated that, the hardware, the serial number, the IMEI of the hardware needs to be tied in on the network side with the SIM. That means that it cannot be taken out, it cannot be replicated. There's a lot of security around that. When it's moving, there's a lot to do with the fact that we don't, especially containers, which you mentioned. You know, as long as there's cellular connectivity, we could do that. What was already a theme around everywhere. I think we've announced that a few weeks ago. So Skylo being a satellite narrowband provider, as well as Telit Centurion, who we work with closely at Flow, and Flow have provided sort of the release 17 3GPP. Those new modules are both cellular as well as terrestrial, and I think that comes to solve the issue of those moving devices. If there's cellular connectivity and these are moving around, you know, Europe, and they're moving from country to country, I think that what we see is that we need to be able to provide that consistency level, but also there's GDPR consideration, but you also want to make sure that you always have the strongest network. So you need, again, as what I'm mentioning on the presentation, more than one network in each country, so a multi-net solution. And you need to be dynamic enough to never lose control. So with these devices, you never want to go back to fix them if they're on a container. One thing I will say is the worst thing you can ever do is build a fixed device and then go and fix it. You know, then go and sort out why the connectivity's not working. It's the most expensive thing that you can ever do, is to send an engineer. One is a problem, 50,000 is sort of a catastrophe. So I have a great story in 10 seconds. Rwanda, 2017, 30,000 solar panels with cellular connectivity. I won't go into why. Need to go and replace. Now, solar panels on top of the roof. Just think about you know, the catastrophe of sort of a business gone bankrupt at sort of just that moment.
Right. So we have a lot of hardware design engineers at Embedded World, and when I think about that matrix that was shown, and I think we all kind of talked about the IoT complexity, when should an engineer who is designing a product really start paying attention to the antenna? You know, they're probably focused on the engine, the motor, as you said. Great car, great motor, I need to buy tires. When should they start thinking about the antenna design? And we'll start with you, Aitor.
Well, as I said during the presentation, and as Carmen said, from the very beginning, at the end, when you are designing a wireless device, the antenna is a key component, of course, as it is the module and the network afterwards and so on. But the antenna plays a key role on making that product really working. No? So that's why we hopefully expect that people start considering the antenna from the very beginning, and that's also why, you know, as also Carmen was mentioning, we provide tools to support during this process of understanding, okay, what is actually the antenna I need, which are the frequency bands I need, because actually I was talking yesterday to, and it's a little bit of a side conversation of your question, Fred, but if I could.
Please.
So yesterday I was having a chat with one analyst from Omdia, and he was saying that they went through a massive survey, and maybe you have seen also right in your side, and 25% of the people said that the most challenging thing is selecting the right frequency bands for their device. No? And it's not totally directed to the antenna, but it has a huge implication on the antenna. So definitely it should be one of, if not the first, maybe it's too optimistic, thinking it as the first thing you think about. It should be one of the first things you consider.
Okay. Adding?
I would like to add something. An example that is, you know, for me resonated a lot when we start seeing it, and is the awareness. So when you are certifying your IoT device, depending on the operator, you might have different specifications. So if many of you are doing devices for example, American market, you can see that, for example, AT&T, if you have a device below or shorter than 107 millimeters, you will be considered a small form factor, right? So then you will have lower specifications. Something very surprising for me that I learned some short time ago was, like, for example, in Verizon. Verizon is not based on length, it's based on surface, right? So for them, a small device is 2,500 millimeters square meter. That's considered a small device. So imagine you have defined all your device, you have made your testing, everything, you come to the end, and suddenly you realize your device is not actually considered a small form factor. That means that instead of having 10 dB as a dBm for TRP, you will have 18 dBm TRP. If you reduce few millimeters that device, your performance will be lower, but your specification will be 8 dBs lower, which is completely different. So if you really think at the end, you have to basically remake the whole device. So it's actually much more important even than what people think. So that's why I wanted to bring some awareness to the people.
Well, you took my very next question, but
Really?
yeah, no. So, but I think it's interesting because if you're a mechanical engineer and you're working around form factors and productizing and in the idea of a product, you probably aren't thinking about bands and connectivity and the specifications and requirements changing based on a few square centimeter change of a product size. And that was new to me too yesterday when we were prepping for the panel. So very interesting highlight. This industry is described by all the panelists that IoT is a little bit complex because it's a very complex stack of participants. The ecosystem is pretty deep. From antennas to board builders, a lot of firmware, a lot of software, networks, applications, clouds, and quite frankly, too many projects do indeed fail, right? And fewer every day are failing because the ecosystem's getting better. But you mentioned this matrix in knowledge, and the fact that there's not always enough people in your companies to potentially solve these problems. So you need to lean on your supply chain. Talk to me about how AI helps the knowledge gap.
That's a good question, Fred. So actually, well, I think we all share that view, as you said. IoT is complex, and we try to provide tools to our users and customers to make that as simple as possible for them. And that's why some time ago already at Ignion, we start thinking, okay, we need to make that step of the antenna selection much more easy. It's still complex. It's still have a little bit of uncertainties if you are not an RF specialist or if you are not into the antenna space. So we need to make that as easy as possible. So we started with a form, the Antenna Intelligence Cloud. Maybe you've seen it. And actually, we have taken the next step by creating this new platform where we have embedded a new ML model. As I said during my presentation, it's totally developed by us. It's owned by Ignion. And what it does is actually helping people understanding design iterations. You were also talking about mechanical engineers, maybe not knowing a lot about antennas and so on, just as an example, nothing against mechanical engineers. So you may have an enclosure and you may need a screw on a certain corner, and Ignion in that case is recommending to locate the antenna in the corner of the PCB, but maybe this is not an option. So that's why you can just have in an interactive area different tweaks in your design, change antenna location, change the clearance area, and get in real time the performance impact. Because maybe the first solution we recommend, it has really good performance, but you are okay with half of it. So you can still get into the performance you want by adjusting some of the parameters that we provide. And that's why we're using AI as the one supporting this model.
Excellent. So when we think about engineers, design engineers and embedded engineers in there, we did a survey. The IMC did a survey with a bunch of the users and consumers in the embedded market. And we tried to understand how many people were making, radio decisions or radio buys and making connectivity in operator decisions at the same time. Were they buying, the connectivity hardware and the service and making those decisions early? And some of that is being pushed into the answer of yes, we need to be considered because there's embedded SIMs, there's iSIMs, there's soft SIMs, there's all kinds of things where before they kind of put a SIM socket in there and they said, just let my customers worry about it. But products as a service also mean that if you're an OEM, you want to get to that product and maybe do updates also. So there's connectivity's more in the forefront when people are designing. How does floLIVE's model make that more important, or do they have to worry about it less?
I'll start from backwards. The first consideration is what is your market, who are you selling to, what's the application, and taking it backwards from there. That's where we're pushing that's where we're pushing to help our customers, trying to understand what's the application. Then I said, is it battery operated? Is it fixed? Is it not fixed? Is it moving around? How many countries are you going to be affecting certain countries? Certain countries have more challenging requirements. Certain countries are tighter on privacy rules and require the data. Certain countries don't allow you to be there for more than sort of 60 or 90 days on roaming. So if you've got a transient device or things like that. So going back to your question, how do we help them? We have that knowledge base. We have the network that allows it. to be flexible. We have the business decision capability on the network side in order to switch the correct connectivity on the actual SIM itself from afar. We also like to put some connectivity insurance, as we call it, by adding an IMSI that will always work somewhere in the world. So if that device, as I said, if you don't want a device that goes dead, is not something that you can recover. It's not like you can take it out of your pocket and restart the phone. You know, you've got a device that could be hundreds of dollars. You've got a customer paying it for it. You don't want to be able to lose that. So that insurance adds up. That's all part of the network side, giving some capabilities on the SIM side, and we put that IMSI in the insurance as an insurance almost. And we call it's what is called in the industry a bootstrap IMSI.
Yep.
And that sits inside the logic of the application that runs on top of the SIM.
Yeah.
So if that answers all of it. I do want to say sort of one thing, but something that happened to us with a customer with an e-bike. And you know, somebody's designing an e-bike and everything's great, and they've got sort of the board and they've got the SIMs and everything's working fantastic. You can go and deploy it inside an aluminium frame and something like that, and it all sort of behaves differently. That's where the first time I sort of heard the word antenna. You know, like one of our customers a couple of years ago. First time I ever heard, God, there's actually antenna people involved in this sort of world of ours. And you know, maybe we sort of put the antenna on the side, and suddenly you get into material sciences as well. People are saying, you know, oh, this plastic is no good. This plastic directs it this way, directs it that way. It's sort of a very fluid thing. It's the first time I ever heard that we've got some industry friends who are in the antenna business was the bicycles. And
well, I can tell you an example. It was even more surprising for me when, you know, we have a customer when we have these flexible PCB antennas, right? And when I went there, he was totally angry, like, your antenna doesn't work, this is horrible. And I was like, okay, can I see? And when he brought the device, he taped the antenna on the shield can of the module. And he was complaining it was not working. He just put it on the metal, on the PCB, and I said, well, you could have sent us a picture, we would have identified the issue. But it's really a lack of awareness of many people. I mean, they are very good RF engineers, but the antenna, as they always say, is a bit like a magic box. And I think it's very good also to educate our customers and to make them understand that consideration is not as scary as it looks like, actually. So.
Right. Do we have any questions from the audience? Any thoughts, any questions? So one of the things that's interesting in the embedded world is, and let's take the e-bike example. I might do a motor controller for an e-bike, but I'm not an e-bike company. See, that's the difference. So Rony, you said, I not know where my product's going and what it's doing. There's a lot of people in this conference that build a sub-assembly. They hope to sell it to everybody. Every e-bike. So they need to try to be as flexible and accommodating and almost postpone some of these tunings for where I might be successful. So think through those optics. How does designing for the antenna and designing for the network change in that once removed from the customer model?
I think
maybe it's the same. I don't know.
Yeah. I think there is a part where there, you know, I don't want to talk about sub-assembly because that's sort of less my area of expertise, but I do think that along the way we've seen the successful ones, successful projects, be sort of devices that are targeted for their audience. And most of the devices, if we take sort of Qualcomm Aware, if you ever seen the Qualcomm Aware platform, people take that platform and build other applications on top of that. So you've got a very good solid base which you could use, and that's sort of as an example of a good base. Or there's lots of good boards. It's what you do afterwards, and you've got to have that solid base as sort of with the maybe perhaps the widest common denominator, if that's a good word for it. You know, the widest common denominator for other people to build applications on top of that. I'm perhaps less familiar with the engines. All I can think about is interference and everything else on the telecom side. But definitely sort of the wider common denominator you have when you're building bits of it. And I think we've seen that with how successful the Qualcomm Aware platform is, and people building applications on top of that. There's various other players as well that have done that very well. I think from a connectivity standpoint, we try to take that complexity away, you know, by understanding the requirement of the customer, and understanding where they're going with this. And we ask a lot of questions. We somehow quickly we've become quite good at trying to understand where that's going. You know, if you're going over there and you need that, probably the best efficient, you know, people come to us and say, we're doing 5G because it's the best, you know, but it's not the best. You know, it's high power, it's a lot of bandwidth, it's more expensive. You know, they don't realize that that's. So a lot of times, you know, people come and say, yeah, we want the best, but it's not like buying the best car. It's like buying, you know, it's like an overkill.
So
like
if I'm in
a rocket to try and get to, you know, to Nuremberg city center, so. And it's not necessarily always the right thing to do.
So if I'm an embedded engineer and I'm designing a connected asset, yeah, I want to always have the bootstrap IMSI.
Yeah,
and then I can always mass customize later by FOTA and putting other IMSIs in there.
Yeah,
I mean, I'm trying to give them some practical.
As long as you manage the hardware right, and you've got yourself, you know, if your hardware, you know, does 5G, or maybe it only does, you know, narrowband. You know, there tend to be sort of two groups in the hardware world. It's sort of anybody who's doing low bandwidth, which is sort of narrowband LTE-M,
battery,
you know, or LTE Cat-M1 base, and then the 5G, and then now we're seeing 5G RedCap, and so that's the sort of the two camps on that. And it comes back to everything I said before: high bandwidth, low bandwidth applications. So if you've got your, we could change the carrier. We can inject the different IMSI later on into the SIM card. We can even inject logic into the SIM card and say, yeah, only connect, you know, go back to bootstrap after 3 days or things like that. But we cannot change the hardware. So the reality is the reality. Whatever you've put there in the day dot is your.
Yeah, no, I agree. I mean, you're going to need to know your target. Are you doing a low power, battery powered, blah, blah, blah device, or are you doing a 5G image camera? Different use cases. Yeah. On the antenna side, as we close up, what are some common and most important takeaways you want the embedded community to think about when they think about Kyocera and your antenna tech and how you help them?
So, well, first is we start with the specifications. As Rony said, it's very important to know what you want to cover, right? Some customers want that they won't cover all the bands, and even the module is not covering those bands. It's like, why you want that band is your module doesn't cover it, right? So once you know the specifications, the size is very important, the location of the antenna, so either doing simulations, by experience, etc. So these are the key considerations. Why? Because you need to design the hardware for your solution. So the biggest partners we have for many years, big OEMs, they will come to us and say, hey, this is the bands we need, the modules we need, this is the number of antennas or the connectivity we want, this is the form factor, what should we do, where we put the antennas, how we design it, and then you design everything around it. That's the key for success.
Okay. Aitor?
Not so much to add, but yeah, I completely agree with Carmen. No? That's it. At the end, when you understand your use case and you understand where the product or the device will be operating, and when you know the key elements that impact the antenna space, you are following the right path. No? So that's what we try to do. I think everybody in the antenna domain, in that case, is to educate our customers, our users, towards that line, say towards that direction.
Okay. Rony, if I want to be an enterprise with my own network or an OEM with my own network, can I make that choice with you as well?
Yes, we have some enterprises who are, so I think we all see the car industry is very interested in having their own network. They want to control it. They want to be unified, or in a unified way control all their connectivity. So yes, so there are some enterprises, fairly large ones, who want to have a slice of our network dedicated for them. It's usually really in the form of the packet gateways, because you have devices out in the field, but they'd connect to the nearest antenna, but signaling point of view, they'll only reach a certain packet gateway, and that packet gateway they can control the policy that's coming out. A lot of that stuff isn't even connected to the internet at all, so you can control, create your own packet gateways, but those devices will only be connected to your IT environment, your ERP systems, wherever you're going with that. So that's, I think, on the packet gateway side, that's definitely more a consideration. Core network is really cloud-based environment. The CMP, the connectivity management platform, resides in the cloud, and there's no point in putting that locally. It's actually counterproductive. It's better to be in the cloud, so you can reach it and you can have two geo-redundant sign. But yeah, it can be. I would say that we have perhaps under 10 of such environments, and it's from their point of view. If we wind the clock 10 years back, you would need something probably $200 or $300 million of core network equipment and packet gateways from the likes of Ericsson or Nokia or Huawei to do that. I think today you could do that, on a
SaaS model.
On a SaaS model that cents per month per device.
Right.
Which is unheard of.
So thank you. So to wrap up, IoT has nuances, and nuances means you need some knowledge and some awareness. Hopefully we've given you a little bit of that. We know that we've got a great ecosystem of people to help you. I want to thank you all for participating. And if anybody needs to leave Nuremberg, don't use a rocket, right? Use a known, trusted path. And just like in engineering, try to use as many known, trusted paths as there are, and leverage the people and the skills and the folks that hopefully you've been introduced to today. So on behalf of IMC and the panelists, we want to say thank you. We wouldn't have a panel without an audience. And I really, really hope you had a great embedded world and a safe trip home. Thank you.
Thank you very much. Thank you.